Hi everyone, thank you for joining today. My name is Maarten Mulders and I work with a Dutch company called InfoSupport as a consultant and a trainer. And today I would like to discuss Dapr with you. The main question for today is Dapr a dinosaur in a fancy suit or is it the developer's dream come true? Let's get started, shall we? So as I said, I work as a trainer and a consultant. As a consultant, I'm often consulting clients of ours in a role as an architect. And as an architect, there's one thing that really gets me up in the morning, that really makes me tick, and that is solving complex problems. Now, if I say it like this, it sounds like a very generic statement. So let me add a little nuance. I believe there are two types of complexity. The first one is essential complexity, which is all about solving a complex business problem. It's the complexity that we inherit from the domain, from the problems that our clients ask us to solve. That's the good stuff, if you ask me. But there's also accidental complexity, complexity that comes from the solutions that we chose earlier, complexity that comes from, yeah, but we might eventually want to scale out, so let's make sure we already are prepared for it. That's not the type of complexity that's, to me at least, the most interesting to solve. We just need to, but it doesn't really address our customers' need, only in an indirect way, maybe. To illustrate this, let's look at an example. Imagine we are solving a business problem and we need an application for that. The business ambitions are great. They are sky high, so we expect that we will need to scale out. Our application must be able to run in one, two, or, well, who knows how many instances. We just can't predict. Now, our application also needs some kind of storage. We don't know yet what kind of storage we would like to use, but we know that the storage requirements are relatively simple. We have a key, we want to store some values with that key, and we want to be able to retrieve them later. It's as simple as that. Now, the idea is simple, but how are we going to implement it? All the instances of our application need to be able to communicate with the same shared key value store. Will we be using Redis? Or given that we already have a database, shall we just reuse PostgreSQL? How about Hazelcast? Or if we are running in some cloud environment, did we consider the cloud services that come on that cloud environment? We don't know, but it's, well, if we don't make a choice, we can't get it working, so we need to do something. And at this point, I'm remembered by one of my colleagues. Hey, that picture of you that is running, it is on the wall somewhere in our headquarters. What does it say again? Oh yes, I remember. It's a quote of me saying architecture is all about making choices. That's what it is. But let's not do it too quickly. If we can postpone such a choice, that's a good thing. So let's try to make them as late as possible. Hmm. Yeah, you're right. So maybe we shouldn't make a choice yet about Redis or PostgreSQL, Hazelcast or what else. But how are we going to be able to make a switch later if we don't, if we just tie ourselves into one of them? Would there be a standardized API that covers all of them? Yeah, good luck finding that one. The best thing I can think of is Java util map interface. But if we are going to implement that ourselves, our application still needs to know about Redis. It needs to know about PostgreSQL or whatever storage technology is underneath it. So that is not really going to help us in the long run. What else do we have? Well, if you are around in the industry for a little longer than I am, you may be familiar with the Jakarta 2 Enterprise Edition platform, later named Java EE, now it's called Jakarta EE. And Well, it certainly has its age. Its first version was released in 1999, long before I even joined the industry. So, Dinosaur refers to its age. It's not about being outdated or irrelevant because I really believe the platform has value as of today. But historically, Java EE or Jakarta EE has always focused on providing abstractions for specific technology so that applications can become portable. We can easily port them from one database to another, from one message broker to another, so on and so forth. Sounds great, but it's not going to solve this problem for us because this is not about two two pieces of technology that are roughly the same, one database or another. It's about a key value store versus a database versus something else. Also, let's be honest, it adds a layer of complexity in our solution. Not only do we have our application running in the Java virtual machine, there's an extra layer in between, the Jakarta EE container. And we already have so many layers, the hypervisor, the Docker container, the Java virtual machine itself, plus our application. So no, that is not really solving our problem at this point. Can't we think of something simpler for this? And this is where I would like to introduce to you Dapr, the Distributed Application Runtime. It's a runtime environment for building microservices or distributed systems, as I prefer to call them, that are event-driven, and the platform itself is portable. It's suitable for deploying on both cloud and edge infrastructure. Dapr recently announced that they will be joining the Cloud Native Compute Foundation, so that is also promising for its future. So let's open that box of Dapr and find the ingredients in the box. Or if you wish, it's kind of a buzzword bingo, so make sure to have your card at hand. Here we go. First of all, Dapr is open source, meaning you can inspect how it works, you can browse through the source code, but you can also contribute new ideas, implement them, or fix bugs. It's polyglot, meaning that Dapr does not require you to use a particular programming language for your business, so, for your business problems. Dapr itself, of course, is built at this point in Go, although there are some plans to also support other programming languages. Dapr is modular, and we will see a lot of that in this talk. And it's also pluggable, so if there's no module that fits your needs, you can plug in your own. And finally, it's cloud native, meaning it will certainly feel at home if you deploy to some kind of cloud platform. So that's quite a bit of ingredients. Oh, little disclaimer, there may be traces of nuts or gluten and other allergens, but let's hope that they will not bite us today. So the main concept that Dapr is built around is a building block. And a building block is a description of a cross-cutting concern that we can face when we build a distributed system. We already saw one of these in the intro, which is the concern of having a key value store so that we can store some data and share it with all the instances in our application. But there are many more, as we will see. And for such building blocks, Dapr provides APIs. Here's an example of the state store API, which is how the building block for key value store is officially named. So what do we see here? First of all, we see that we initiate a connection to localhost 3500. We'll see in a few minutes what is there. We do a post on v1. We want to invoke the state API. The state store is named vehicles, and here we pass an array with key value pairs. The key being this little string and the value being a JSON body. It doesn't have to be a JSON body, by the way. It can be any string. It can even be base64 encoded binary data if you wish, as long as you can eventually make it a string. A second endpoint of the same state API is this one. You can perform a get on v1 state, then again the name of the state store, and then the key for which you want to retrieve the value. And you will be answered with the value that you have that you have stored before. So that's all great, but then immediately the question arises, this localhost 3500, what is that? What is running over there? Well, that is the Dapr sidecar. This is the standalone mode of the Dapr sidecar, where we have two processes running on our machine, the Dapr sidecar and our own application. And the application and the Dapr sidecar communicate with each other over HTTP or gRPC. And again, the Dapr sidecar is actually providing the building blocks. Now, this is the standalone mode. There's also a Kubernetes mode where we would be deploying the sidecar and the application in two containers that together form a pod. And also in this scenario, the application and the container talk with each other using either HTTP or gRPC. Now, the building block consists of an API. I've already discussed that one. That's the HTTP API or the gRPC if you wish. That API is implemented using various techniques. For the state store, we saw already that there's a Redis implementation, a Hazelcast implementation, a PostgreSQL implementation, and there are many more. But the good part is that the public API, the HTTP or gRPC API, does not change whether you're using one of these implementations. So that's great. Our application is not aware of the underlying implementation. It just needs to follow the HTTP API. This may look to you a bit like a service mesh, a sidecar that is running side by side with your application and provides some additional services. Well, a service mesh really focuses on infrastructure concerns. And that is where Dapr differs, because Dapr is not so much concerned about infrastructure as well as on application concerns. And we will see many more in a few minutes, but for now we only saw the state store. But all the things that Dapr offers to your application are not infrastructure concerns. They are really enriching the behavior of your application in a standardized way. So let's look at our first demo for today, the key value store in action. Our scenario is one that, at least in the Netherlands, is rather common, maybe also in other countries. On many highways in the Netherlands, you will find these kinds of installations. This is a little camera. There and there and there. For each lane on the highway, there is this camera, and it will register each vehicle that passes underneath it. So here's one camera, there's another camera, and there's my car in between. Now, when I drive under the first one, my car is pictured, the license plate is scanned, and that is sent to a traffic control system. And when I pass under the second one, the same happens, and that's also sent to the traffic control system. The remainder of the diagram we will be discussing in a later stage. And this traffic control service is actually using a state store. So given my license number as a key, it stores when I enter the system and when I leave the system. And if there's not enough time, and it calculates how much time there is between those two registrations, it of course knows the distance between those two cameras. And using that information, it can calculate what my average speed was. If my average speed is too high, it can determine that I need to get a speeding ticket. So this first demo, I will be starting the Dapr sidecar, start the application, which is the traffic control system, the first one, and I will use that to store and retrieve some data. First, let's start the sidecar and the application. We're doing that in one shot. Oops. So, yeah, there we are. Dapr run. The first thing I'm passing is the name of the application. So my application now has a logical name, independent of where it actually is deployed. My application will be listening on port 6000 and the sidecar needs to know that. The sidecar also needs to know where to start listening for calls from the application. HTTP port 3600, gRPC port 60000. And it will actually use that and set environment variables for the application command that comes here. Maven Spring Boot run. Oh, and I need to pass the folder that contains my Dapr configuration. When I do this, the sidecar starts, blah, 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 blah. Then it starts my application. That was Maven Spring Boot run. And now we've got everything started. Great. I can simulate my car entering the system for the first time. And in this folder that I used to configure Dapr, I said, hey, I want to have a state store, which is backed by a Redis store. So let's look into my Redis store already and say getAll. First, I give it the name of the application that is consuming the state store, which is traffic control service, followed by the key under which I stored some value, which is this one. And then what I can see is it actually stored the data that my application was putting into it, which is just a timestamp that my car entered the system. And it's the first version for this key. Now let's get back here and simulate my car passing under the second camera. Up. Going back to Redis, requesting the same key, we now find that we have an entry timestamp as well as an exit timestamp, and that's the version of this record has been updated to version 2. Now the good part of all this is that the traffic control system does not know it is talking to Redis. It's talking to an HTTP API. It doesn't have any knowledge about Redis. That's great. So, what else do we have inside Dapr? What other components can we use? Well, we already saw the state store. There's service invocation, pub/sub, bindings, secrets, naming resolution, and middleware. And they are actually adding new components as we speak, which are not yet in the list because they are not yet finalized. For all of those, there are already more than 27 implementations available, both for products that you can install and run yourself, but also for various cloud services like message brokers or whatnot. So chances are pretty big that whatever you already have is covered by it. Let's dive in a little bit. So the first component that I would like to discuss is service invocation, a relatively classic pattern where one application sends a request to another one and the other one sends back a response to the first one. You could say, well, this is pretty common. Why would you be using Dapr for it? Well, one reason could be that rather than knowing the address of application 2, application 1 only needs to know the name of it. So it needs to know that there is, let's say, a fine collection service, but it doesn't need to know what the exact address is, because that's what Dapr will take care of. Another very common pattern in distributed systems is pub/sub, where one application publishes an event in a kind of fire and forget style. So it doesn't wait for an answer, it doesn't wait for a response, it just publishes the event to some kind of broker or message bus. And then other applications may subscribe to that event, to that fact. And the good part is that the first application does not need to know who is going to be subscribed to it. It just publishes it. And all those applications that are subscribed to it will receive the event, but they don't know about application 1 from their side. Bindings come in various sub-flavors. There are outgoing bindings, like example, sending out an email, sending out an SMS message, invoking a remote web service. And there are incoming bindings, for example, a cron schedule that will trigger your application at a specified pattern. And there are also bidirectional bindings that allow communication both incoming and outgoing of your system. There's a component to retrieve confidential information like passwords or API keys or that kind of stuff. The thing that you don't want to have in your source code, don't want to have in your Git repository preferably, but you need to store them somewhere. The good part is that there's, for example, one implementation of this component that uses a local JSON file, which is great for debugging and for developing on your own machine. But there's also implementations for various cloud services or, for example, HashiCorp Vault. But again, your application doesn't need to change because it knows the HTTP API for this and it does not know how it is implemented. So let's look at a second demo where we see, among other things, service invocation and output bindings. We have the same setup as before. I already explained about the cameras, sending pictures of vehicles with the license numbers, and the traffic control system that will calculate how fast somebody drove. Now, if somebody drove too fast, the traffic control system will publish a speeding violation event. Just saying that somebody drove too fast, or actually some car was measured to drive too fast. The fine collection service is subscribed to that kind of event. It will pick it up and it will determine what the exact amount is that the user needs to, that the driver needs to pay. But who is that driver? Well, for that it uses service invocation to actually fetch the vehicle registration using the license number, and it will get back the name and the email address of the person who registered the car. So what we will be doing in this demo, we will again start the application components using their sidecars. We will start a helper program that simulates a bit of traffic, and we will see if the speeding tickets are indeed delivered to the drivers. So we already had the traffic control system running. I'm going to start the fine collection service, which is similar to the traffic control system, so I'm not going to run through the whole command. And I'm going to start the vehicle registration service. Let's wait for them all to start. They're all started, great. And here I'm going to start a little simulation program that just randomly simulates cars driving over this highway. There we have the first ones at the first camera, and there we have the second camera also registering vehicles. They are all measured by the traffic control service, checking that they didn't drive too fast. If we look at the fine collection service, we see that it has already sent some violations. So let's see if those tickets are actually received by the drivers. Well, there's quite a lot of messages already, and we can even see them flowing in as we speak. We can see information about the car, about the violation, when exactly it was measured, and also how fast the driver drove and what the sanction amount is. Well, this person was really driving a lot too fast, so we don't even know exactly how much they need to pay. We just know that the prosecutor will eventually determine the amount for that. And others will just receive a ticket saying, hey, it's 130 euros for you. So that's all looking great. Speeding tickets flowing in. Now, Dapr is really targeted at distributed architectures. And if you are building distributed architectures, one thing that is really going to save your day is observability. Observability comes in two two flavors. The first one is tracing, and the second one is metrics. Let's see what they are and how Dapr can be of help. So tracing is the idea where every kind of interaction between two components of your architecture is enriched with some tracing information. This is typically done using custom headers or message properties or whatnot, depending on the transport mechanism. And all the applications pick up incoming headers and propagate them to the next component that they invoke. They also collect information about the steps they perform themselves, and periodically they submit that kind of information to a central system, for instance, Zipkin. Zipkin will then collect all that information and provide nice visualizations, which can help you troubleshoot performance bottlenecks, for instance. Metrics, on the other hand, are kind of measurements. So your application will measure certain things. Those can be business metrics, like how many users signed up today or how many products did we sell today. Or there can be operational metrics like CPU usage, memory usage, and whatnot. And uh, then again, the central tool collects those measurements. It's using a process called scraping and converts the measurements into time series. And you can use different tooling like Grafana to visualize the dashboards. So Dapr actually exposes a few metrics itself. It tells, for instance, to Prometheus how much CPU and memory usage did it claim. If you run it in secure mode, it will expose a few metrics about certificate issuing, and in general, it will just say how often certain sidecar operations were invoked. Tracing. Oh, and you can expect dashboards like these that visualize that. For tracing, it's a bit more complex. The typical approach, as I said, would be to inject some headers, for instance, on your HTTP calls. And that would in this case mean that you are inserting those headers on the HTTP calls to the sidecar. I didn't include them in this example. This is how the regular API call would look like, and then you would add some headers for traceability. But that's going to be complex and it requires a lot of maintenance on your side. And that's where the Dapr SDK for Java may be of help. It's published to Maven Central under these coordinates, and it exposes, among other things, a Dapr client class. Let's say we want to do a remote method invocation, invoking an API on a different application. We could say we invoke a method on the vehicle registration service. The name of the method is vehicle info plus the license number of the car. We do an HTTP GET, so we pass no request body. And the response that we get back, we want to convert that into an object of the vehicle info class. That would work in itself. It will give you, it's all built on Project Reactor, so it's all reactive, so you need to block on that or pass that context on. But being implemented on top of Project Reactor, you can use context write, this method, to pass additional information into the reactor context. And the type of information that you would like to add is the tracing context that you can get from Open Tracing or Spring Sleuth. How exactly to do that is a bit outside of the scope for today. But let's just say for now that this is the way how you would add the tracing information. There's also an SDK specifically targeted at Spring Boot, which allows, for instance, for easy subscription to pub subtopics. If you already have a post mapping on a method, you can add a topic annotation saying the name of the pub sub broker is pubsub in this case, and I would like to subscribe to the speeding violations topic. And then whenever an event is published on that topic, it will be sent to this method in a cloud event wrapping the underlying speeding violation class. So, what would that look like? In practice, Here we have zipkin running. We can start looking for traces. Let's see. Let's see again. Yeah, there's an entry cam method. That's great. That's the first registration of a car. The picture is sent to the entry cam topic, and the traffic control service picks it up and stores the information using the save state method. So far, so good. Then we have cars leaving the system, which did not drive too fast. Similar story. Picture is submitted. We retrieve the state, and then we save the state again, but now with the exit timestamp. And we have the situation where somebody drove too fast. Let's wait for that to happen. Of course, it doesn't happen at this point. Yeah, then we have one. So, car entering the system, save state, same as before. We store when the car was passing by the second camera, but this time the car was detected to have been driving too fast. So we publish the event, then the find collection service picks up the event and invokes its collect find method. Well, to find the vehicle registration, to find the owner actually, we use the vehicle registration service using the license number, and that call returns in 1.9 milliseconds. As you can see, all calls are annotated, how long did they take, and we can easily visualize where the potential bottlenecks are in our architecture. So that's great. It's time to get back to our original question. Is Dapr a dinosaur in a fancy suit, or is it a developer's dream come true? Let's start with the first one. Is it a dinosaur? Well, Dapr is certainly something else than the Jakarta EE platform, that's for sure. For instance, the Jakarta EE platform requires you to be running on the Java virtual machine, while Dapr, on the other hand, says it doesn't matter in what programming language you solve your business problems, as long as you can speak to an HTTP API or a gRPC API, it's all great. And for various popular platforms, they even provide an SDK so that you can do it with even more convenience. Also, and maybe even more importantly, Dapr does not abstract over similar technologies like SQL Server and Oracle DB and DB2 all being relational databases, but it rather abstracts over a concern that your application may need. For instance, storing data using a key value mechanism. And you could implement that on various technologies, one of them being a relational database. But there are other options available as well. So I would say it's definitely not a dinosaur. That one got busted. But then, on the other hand, is it a developer's dream come true? Well, Dapr does provide SDKs for various platforms, but I have to be honest about this. Not all SDKs are created equally. The SDK for .NET is very mature and provides a lot of functionality out of the box. But something as crucial as distributed tracing, well, you can get it working using the Dapr SDK for Java, but it requires quite some code still. While the Dapr SDK for .NET requires exactly 0 lines of code for that. It works out of the box. Everything is instrumented for you without you even knowing it. In the Java world, you have to do it manually. And the same holds, for instance, for the Python SDK. And that's not to blame people, it's just saying that not all integrations are as mature as the others. Also, Using Dapr adds a new piece of technology to your application landscape. And that's something that you need to be aware of, that you need to be uh, ready to accept. So this sidecar is of course great because you don't need to care about uh, 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 whatever database is underneath it or whatever message broker is underneath it, as long as you understand the HTTP or the gRPC API. But what if things don't work as expected? Can you troubleshoot it? Can you debug it? That's a different thing that you need to be able to work with, and that can in itself pose its own challenges. Also, you might think, hey, I have this sidecar. I chose to run PostgreSQL behind it, but that doesn't mean that you can use all of PostgreSQL features. You can only use the stuff that is exposed through this API, and anything else you still need to code that yourself using the SDKs that are appropriate for it. So is Dapr a developer's dream come true? Is it the next big thing? Well, I would say not yet. At least not yet, but it definitely has its potential. At this point, I would certainly not say let's convert all our application architectures to Dapr, because many of the concerns that Dapr solves for you, you may already have solved yourself using third-party libraries. On the other hand, if you're starting out on a new project, it may be something to consider. Would it be a good idea? And I'm not saying it's always a good idea, but it could be beneficial in your situation. So we've almost come to the end. There's a few things that I would like you to take away with regards to Dapr. What is Dapr all about? Well, Dapr is all about abstracting the cross-cutting concerns in your distributed application landscape. Common integration patterns solved using standard building blocks, which you can invoke using APIs over HTTP or gRPC. But this all doesn't work out of the box. You need the sidecar for that to work. And the sidecar is actually the thing that powers your vehicle, your application. The sidecar will bring you to the destination where you have addressed that particular concern. But please be aware, Dapr is not a one-stop shop that will solve all your integration problems. It's not a Swiss Army knife either that you can use for all your database interaction or all your message broker interaction. It solves one thing, and if you need something else, well, maybe Dapr does not offer that to you. Now, if this got you curious, I've got a workshop for you that you can do. It's up on this link and it will redirect you to GitHub. The workshop consists of 7 assignments, which you can run in 2 modes. The first one is more freestyle, where the assignment says this is the current situation and this is how it should end up. Here are some links to relevant documentation. Good luck. The second mode is called step by step. And there we will exactly tell you how to do it, when to do it, why to do it, and how it's going to work. I would love to hear your feedback on it. You can run the workshop at your own convenience in your own time. And if you have any questions, feel free to reach out to me. My Twitter handle is down there. And also I'm taking feedback on GitHub if you prefer that way of communicating. So with all of that, I would like to thank you for your time and attention, and have fun doing the workshop if you choose to do so.